Okay, the third derivative of carboxylic acid is acid anhydrides. Okay, and acid anhydrides actually came from two carboxylic acid molecules joined together by removing the water molecule. So if this is carboxylic acid 1 reacting with another carboxylic acid, the mechanism will be hydrogen will be removed from the first carboxylic acid, hydroxyl group will be removed from the second carboxylic acid. These form two bonds to form water, and the remaining will bond together to form the acid anhydrides. Okay, sorry. This is this the oxygen is included there, and that one would be reacting. So we have RC double bond O, C double bond OR. This is the acid anhydride. Take note that the word anhydride means without water. So the water has been removed so that they could form bond together. Now, how do we name these acid anhydrides? If the carboxylic acid used was the same, so symmetrical acid anhydrides having the R groups are the same, there you have to use only the name of the parent chain or the name of the parent carboxylic acid, removing the word acid and replace it with anhydride. So this is the R group and this is another R group. They both contain two carbon atoms. So originally they came from ethanoic acid. Okay, so with this we are dropping the acid and replace it with anhydride. Therefore, the IUPAC name is ethanoic anhydride. It came from two molecules of ethanoic acid. The common name, since ethanoic acid has a common name of acetic acid, okay, we are dropping the acid name and we are adding the anhydride. So therefore, this acid anhydride will have a common name of acetic anhydride. Okay, how about if the R groups are different? You have to name according to the parent individual parent carboxylic acid, and you have to arrange them alphabetically. Okay, so this R group has three carbon atoms, so therefore this is coming from propanoic acid, and this has two carbon atoms, so meaning it came from ethanoic acid. So arrange them alphabetically, ethanoic first, then followed by propanoic. Acids are now being dropped and replaced by anhydride, so therefore the IUPAC name for this would be ethanoic propanoic anhydride. Take note that there are spaces in between these three words. Okay, now for the common name for this three carbon atom as a carboxylic acid is propionic. Take note it is propionic, and the IUPAC is propanoic. While as these two carbon atom has a common name of acetic acid, so therefore arranging them alphabetically, acetic came first, then followed by propionic. Acids are being dropped and replaced by the word anhydride. So therefore, the common name for this structure is acetic propionic anhydride. Okay. What are the properties of these acid anhydrides? The most important acid anhydride is acetic acid. Acetic anhydride. Acetic anhydride has been very useful as a raw material for cellulose acetate fibers and plastics. Okay, so that's why it is the most important acetic anhydride. Aside from that, it is also used for drugs, for the synthesis of aspirins and acetaminophen and other pharmaceutical products. Okay, aside from being used as a of fibers and plastic, it could be for aspirin and acetaminophen and explosive also. So very useful ang acetic anhydride. That's why it is the most important acid anhydride. Nevertheless, acid anhydrides are very reactive compounds, and although they are generally not as reactive as the acid chlorides, they still do not exist in biological system because they undergo hydrolysis, or that is the reaction with water to regenerate the parent chain or the parent carboxylic acid. So how is this? They easily reacts with water, and water could be written as HOH. Okay, so the mechanism will be the hydrogen will go back to first carboxylic acid, and then the hydroxyl will go back to the second carboxylic acid with this bond breaking. So therefore, we're going to go back with the two individual carboxylic acid once these acid anhydrides react with water.